I'm Dr. Angela Hornsby, and I'm the curator of the Philip L. Wright Zoological Museum here at the University of Montana. If you've been to a natural history museum before, you probably wandered through huge halls that were filled with displays, dioramas, skeletons, mounted specimens, and tons of information geared towards public engagement and education. But most natural history museums have another side that you probably didn't get to see and may not have even known existed. That other side is dedicated to research, and it's where the museums keep their hundreds, thousands, and sometimes millions of specimens that are used for scientific purposes. You can think of it as a kind of library of the natural world, and the Phil Wright Museum is one such library. Right here on the UM campus, we keep about 25,000 specimens focused on birds and mammals of the northern Rocky Mountain region. Altogether, natural history museums like this support a huge variety of research. One of the underappreciated roles is as the foundation of biodiversity research. Museums are the reference libraries of life. What is this species? Where is it found? How can we distinguish it from other species? How much variation does it exhibit, either through geographic space or through time, and across individuals, sexes, ages, and populations? All of these questions are fundamental in all of our work describing the patterns of life on Earth. But that's just the beginning. We can use specimens to tackle many types of questions across biology and environmental science. Specimens from the Phil Wright Museum have been used recently to determine the genetic basis of snowshoe hare coat color change across seasons, study the effects of nutritional stress on tooth and jaw development, determine historical genetic patterns of sharp-tailed grouse in western Montana, and use stable isotope analysis of fur samples to piece together migratory behavior of silver-haired bats. Critically, not only do museums provide specimens for research needs that we have today, but we also save those specimens for research needs in the future. We can sometimes anticipate what those needs might be, but other times we'll be surprised based on technological advancements and changes in the world that we didn't anticipate. Either way, keeping those specimens long-term in good condition is our best way of preserving our opportunities to even ask those questions. So now that we've talked about the purpose of research museums in general, let me tell you a little bit more specifically about the Phil Wright Museum at the University of Montana. This museum began in 1897, just a few years after the university itself was founded. It started out as the personal collections of UM's first biology professor, Morton Elrod, who brought his own specimens to campus for use in zoology classes. Some specimens were added in those early decades, but it wasn't until Phil Wright took over in 1939 that the museum really started growing. Most of our specimens were collected by Phil Wright, his students, and even his family over the course of several decades. In 1997, the museum was named after him to honor his work and legacy. While many other people have contributed to the museum over time, it was Phil Wright who made it what it is today. Between 2016 and 2019, the museum underwent a huge renovation with the support of the UM Division of Biological Sciences, the UM Office of Research and Creative Scholarship, a major biological collections improvement grant from the National Science Foundation, and our donors, the Friends of the Phil Wright Museum. These funds allowed us to make serious updates to our facilities. The major threats to our collection are moisture, light, heat, and insect pests, which are all now extremely low risk. The renovation also updated our work and classroom spaces, improving on the number and types of events and student projects we can support going forward. As part of the renovation process, we also moved our research database online, so now it's all publicly available for free worldwide. The best way to access our collections is through Arctos, which is a huge collaborative database system used by dozens of natural history museums to help make our data clean, uniform, and accessible all in the same place. So that's just a quick overview of our history and mission. Now let me show you some of the spaces where we work. The first stop for most new specimens coming into the museum is the prep lab. This is where students and volunteer preparators take measurements and weight, determine age, sex, and body condition, remove and prepare the skin, take gut and tissue samples for DNA, RNA, and protein analysis, collect parasites, remove the organs and clean off the skeleton, and record reproductive notes. Biological specimens are a treasure trove of information. And that process of trying to collect as much information and as many different materials as possible is called holistic specimen preparation. And really that just means this is our one opportunity to ask that animal about its life, its environment, all of its molecules, and all of its interactions. When we pair all that with the basic collection information of where a specimen came from and when it was collected, suddenly we can start building really big data sets that support the types of complex questions that we're interested in. So what happens to the specimen after we've taken everything apart? It depends on what the part is. Skins of birds and small mammals will be stuffed and dried. If it's a larger mammal, we'll usually tan it instead. Tissue samples from multiple organs will go into our -80 freezer, which is a super cold freezer that helps to preserve the DNA and RNA much better than your standard lab freezer. Skulls and skeletons will dry out and then eventually feed to our colony of dermestid beetles. While the adults mate and lay eggs, the larvae will eat all the extra tissue off the skeleton and in the meantime go through several growth phases called instars. This is an entirely self-contained colony. I don't have to do anything other than feed them and give them a little spritz of water once in a while. They just keep going through generation after generation of skeleton cleaning specialists. Right next door to the prep lab is the skull room. This is our storage space for large, bulky skulls and skeletons from big animals like bison, caribou, moose, and bighorn sheep. This room also serves as our base of operations for specimens moving in and out of the museum. And this is our museum classroom, currently set up for a mammalogy class on shrews. We can rearrange all the tables as needed, making this a really flexible place both for classes and community events. And it wouldn't be a good museum classroom unless we had some nice displays with some of our favorite specimens and some history of the museum for visitors to read. Off the classroom is the storage area, where we keep collections for use in teaching and community outreach. And off of that is the pelt room, where we keep the largest tanned hides. And last, but certainly not least, we have the research archive. This is where we keep the vast majority of our research-grade specimens. In this room, they're in tight, climate-controlled conditions that will help preserve them for decades and centuries to come. The cabinets in this room are on a series of compactors, so if you need a new walkway, you just make one. The compactor system gives us the opportunity to fit almost twice as many specimens as we would normally be able to if the cabinets were static. That means, on a relatively small footprint, we can fit basically our whole research collection with plenty of room to grow for the coming years. We have 3 banks of bird cabinets and 7 banks of mammal cabinets, all arranged taxonomically according to the evolutionary relationships between species. This room also houses our library, including reference materials, historical copies of scientific journals, our old catalog ledgers, and more. We also keep the basic tools needed for specimen imaging and sampling. One of the questions I'm often asked is, why do we have so many specimens of the same species? And this really goes back to the heart of what the museum is here for. By accumulating many specimens of the same species over time and geographic space, we can understand how the variation in that species is structured, understand how it evolved, how it's adapted to its environments, how to tell it apart from related species, and it gives us an amazing baseline of information that we can use for comparison if anything in that species' environment changes and we want to know how those changes affect the species itself. Another question I often get is, why do the specimens look so not lifelike? There's a couple reasons for that, but the primary one is that when all the specimens are prepared in about the same way, it's a lot easier to compare them and start to pick out the differences. The other reason is that this way they just fit well in a drawer. Our oldest specimen is a spotted sandpiper from New Haven, Connecticut, collected in 1882. What's inside of our specimens? Most of the birds and mammals are stuffed with cotton, but sometimes the preparators had to get a little creative. In fact, we found a sharp-tailed grouse from 1897 that was stuffed with sphagnum moss instead of cotton, I assume just because that's what they had available. What's my favorite specimen? I have 25,000 specimens. I can't choose just one. Okay, but if I had to choose, it would be the desman. This is an endangered semi-aquatic insectivore from Kazakhstan, collected in the 1950s. It's a cool case of convergent evolution because externally it looks almost exactly like a muskrat, which is a rodent. But you can tell by the desman's teeth that it's more closely related to moles and shrews. So that one's my favorite, but don't tell the others. While much of our focus here at the Phil Wright Museum is clearly on research, we also do a lot by way of education and outreach. We have a lot of great display-worthy specimens, most of which can be seen at the Montana Natural History Center and in displays across campus. We loan out educational trunks for classes and public outreach events, offer research-oriented tours for groups of many ages, and provide specimens and lesson materials for university education in mammalogy, ornithology, and several other classes. And we have lots of ways for students to be involved in the museum, whether that's as a volunteer, work-study student, independent study, wildlife intern, or through our latest opportunity, the Grassley Curiosity Internship Program, which funds students to pursue their own creative, independent projects in the museum. If you haven't heard of Emily Grassley, and you've made it this far in the video, it's time for you to go look up The Brain Scoop on YouTube. Emily is a UM grad and former student of the Phil Wright Museum, currently working at the Field Museum in Chicago, filming PBS specials and bringing museum research to people worldwide. Really, just go check out The Brain Scoop. You will not be disappointed. Thanks to the University of Montana, the Division of Biological Sciences, and especially our friends at the Phil Wright Museum. And thanks to you for watching. Bye for now.